Alright, now we're going to do Chapter 4, Section 3, using congruent triangles. We'll do this by going over the classroom exercises. You can read the section in the book to look at some other proofs. So, number 1, it says, describe your plan for proving the following, but we're actually going to go ahead and work it out. So, on this one, we've got PQRS. Okay, and we're given that PR bisects QPS. So PR bisects QPS. And PQ is congruent to PS. Okay, so that's the given. Now we're going to mark this in our diagram to help us think about what we're doing. It's very important. PQ and PS are congruent, so that is the same as that. And PR bisects QPS, so we know by definition of bisector that this angle is the same as this one. And we'll go ahead and write that down because that's going to be important in proving that angle Q is equal to angle S. We want to show this one is the same as this one. The top angle and the bottom angle we want to show is true. And we're going to do that by showing that the triangles are the same. Remember, if the triangles are the same, then if they're congruent, then by definition of congruence, by CP/CTC, we know parts of the triangle are congruent. These parts in particular, the two angles. So showing that we have congruent triangles allows us to know that the parts are congruent. First we show triangles congruent, then we can conclude parts are congruent. That's our general strategy. You might want to write that down. Number 1, show triangles congruent. Number 2, deduce parts are congruent. And the general idea for that would be general strategy. So general strategy, number 1, show triangles congruent. Number 2, conclude parts are congruent. Okay, that's how we're going to be doing this. So we've got our given, and like I've said, to show that the triangles are congruent, we need to use these angles. So instead of using a bunch of letters, I'm going to use numbers so it's easier. So angle 1 congruent to angle 2, and that is definition of angle bisector. Okay. Now we've got several theorems to show triangles are congruent. Remember, we can choose from the side-side theorem, which we've already proven, the side-angle-side theorem, or the angle-side angle theorem. You've got to go through these in your head and see which one will work. We don't know about these sides here. I don't think we can show them the same, so this is out. We might have to come back and decide that that's one we're going to use, but for right now, it looks like we can't. It involves cycling through and checking yourself all the time. Angle side angle, Well, if we have this side, we'd have to use that angle for angle side angle. But we're trying to prove that that angle is the same as this one, so that'd be impossible. That'd be circular reasoning. We'd be starting with what we want to prove. So that leaves us with SAS. Let's try to do that. Side, angle, side. Remember, the angle has to be the included one, so we'd have to use these sides here and these sides here. But look what we just did. We went over the same segment. This one is part of angle 2, but it's part of angle 1. That's in both triangles. So we got it, side, angle, side. So we know, and that might be a little tricky, knowing that PR is identical with itself, but we say PR is congruent to PR or RP, whatever. You can call it segment congruence or reflexive, more like reflexive rather than segment congruence, or identity. So say reflexive or say identity, something's the same as itself. And then we know that the top triangle and the bottom triangle are congruent by side, angle, side. So triangle PQR is congruent to triangle PSR, and that's side, angle, side theorem. And then, as a direct result, we know that angle Q is congruent to angle S. And we call that CPCTC. Because when you have congruent triangles, then the parts of the triangles will be congruent, the corresponding parts. So angle Q is congruent to angle S. Okay. You might have to study that, rewind this and go over it again in case it didn't sink in. Let's go on to number 2. Okay. So, same diagram. PQRS and PR bisects angle QPS and angle QRS. So number 1, PR bisects angle QPS and QRS. Okay, and that's given. Now we'll go ahead and mark that. The consequence. Since it's a bisector, if it's a bisector, by definition, it cuts this angle in half into 2 equal parts. And this angle is cut into 2 equal parts. Okay, so I'll call them 1, 2, 3, and 4, so I don't got to write out so many letters. So angle 1 congruent to angle 2, and angle 3 congruent to angle 4, and that's going to be definition angle bisector. Okay. Now remember, we got to use one of our theorems. We got SSS, SAS, ASA, one of those to choose from. Looks like we got two angles, so we're probably going to use an angle. Remember, we want to ask and answer questions to help drive our thinking. Asking and answering questions is important in all areas of life. So start practicing it now so you can train yourself to do it as a matter of second nature or habit. Okay, so we don't have anything to do with side, so it's probably not that. We got two angles. So if we got the side included between the two angles, then maybe we can use this one. And let's see, sure enough, this angle and this angle share this side. So angle 1's here, angle 3's here, and this side is in each of them. Same thing with 2 and 4. They share this, so sure enough, we can use that side. And it's, again, it's just reflexive. I'll call it identity this time to be different. PR is congruent to itself. And that's identity. And then we can use angle side angle to say that the triangles are congruent. Okay? Because in this one we wanted to show PQ was congruent to RS. PQ and, or excuse me, RQ and RS. RQ and RS. We wanted to show these are congruent. And we're going to do that by showing that they're parts of a triangle. If the triangles are congruent, then the parts are congruent. You know, it's a general strategy we wrote down before. Show the top triangle is the same as the bottom. Then you know part is the same as the other part. Okay? So we've got number 4, triangle PQR. Is congruent to triangle PSR. And that's the ASA theorem. And therefore, QR is congruent to RS. With our CPCTC, if you can see it down there. QR congruent to RS. So that, because the triangles are congruent. So, good. Okay. I'm going to stop this video here, and then we'll do number 3 and number 4 in a separate video.